This video is over lesson 92, simplifying complex fractions, and is for my Algebra 1 class. So first of all, a complex fraction is a fraction that contains one or more fractions in the numerator or denominator. In other words, it's a fraction where you have fractions inside of a fraction. So there's going to be the external fraction, which is the whole thing, and then internal fractions, which will be the fractions that are in the numerator or denominator. So there are a few different ways that we can simplify complex fractions, and we're going to focus on two different ways. There are more ways than this. The book actually presents a third. I just think the third one here is kind of unnecessary, which is why I'm not going to focus on it. We'll talk about it briefly, though. So here we go. So first method that we're going to look at is to think of the external fraction as division. So fractions mean division. And then we change it into multiplying by the reciprocal. So in other words, you're going to multiply by the reciprocal of the denominator. The other way to do it is to multiply by a form of 1 that contains the LCM of the internal fractions. Oops, sorry, I forgot one word. Internal fractions, that would be an apostrophe there. Internal fractions denominators. Here. So you look at all the internal fractions, look at the denominators, find a common denominator for all of them, or an LCM. So ladies and gentlemen, we're going to take a look at the practice problems together. So go ahead and write practice here, and then I'm going to ask you to go ahead and grab your books so you can follow along easily. It should be on page 612, so go ahead and pause the video while you open to that. And we're going to get going now. So we'll start with A. And I have x over 4 over, and so when you make a complex fraction, to make it real obvious what the external fraction is, make this fraction bar really big, kind of exaggerate it a little bit. So, and then in the denominator, I have 3x minus 3. So now you can see that my fraction bar really wasn't quite long enough, so I'm just going to extend it a little bit. And then that'll be over x. So for this one, if I look at my two internal fractions, I've got x over 4, and then I have 3 times the quantity x minus 3 over x. For this one, when I think about these two methods, I actually like the idea of multiplying by a form of 1 that contains the LCM of the internal fractions denominators, because this internal fraction has a denominator of 4. This has an internal, has a denominator of x. Well, the LCM there is just going to be 4x. So, oh, I'm sorry. I made another little mistake there. So if the top numerator is just one space, the denominator really should be one space as well. My apologies. There we go. That's better. So again, common multiple here, least common multiple here, 4 and x. I'm going to multiply the top by 4x and the bottom by 4x. So over here, the x in the denominator will cancel the x there. In the numerator, the 4 in the denominator will cancel the 4 there. And so if I simplify this then, I've got x times x, that's x squared up top. And in the denominator now, I have 4 times 3 times the quantity. Well, 4 times 3 is 12, and we can just leave the quantity alone. So my answer is x squared over 12 times the quantity x minus 3. Let's take a look at B. So when I look at B, I have B over CD, and all of that over 2B over C. So likewise, this is simple enough that I could go ahead and just find a common denominator. That is kind of my preferred method, personally. So with a denominator of CD and a denominator of C, they both have C's in them. So we really, common denominator would just be CD. If this just had a D in, they'd be the same. So I'm going to multiply by CD That's my least common multiple on both of those. So up top, CD will cancel CD. On the bottom, C will cancel C. And so if I simplify this, I've got B over 1 times 1. So that's just B. And in the denominator, I have 2B times D. So 2B D. Now, of course, with a B on top and a B on bottom, we can reduce that further. And so now I have 1 over 2D. Remember, if it's the numerator's canceled, it's going to be 1 over something. Now, this is a good time to take a step aside and talk about that third method the book brings in. So I'm going to come over here to my dry erase board and do this one more time with you. So this is something you can do on the homework. I just don't favor it as much, which is why I'm not putting it in the notes. So what the book suggests here is that we actually take this, and multiply by a form of 1 where we use the reciprocal of the denominator. So this would be C over 2B, and then down here this would also be C over 2B. So our form of 1 contains the numerator, or the reciprocal of the denominator. Because then what's going to happen then, of course, is my denominator, well, multiply reciprocals, that's just 1. So up top I would have C and C would cancel, I would have B and B would cancel, and so there's nothing left on top, so that means it's going to be a 1. And on bottom I've got 2 and D, and then of course anything over 1 is just itself. So you can do that. I just don't personally prefer it. If you wanted to kind of go this route, personally I think it would make more sense, we reset this here, to use our second option, or excuse me, our first option of thinking this like division. So this is really the top fraction, so B over CD, divided by the second fraction. So we can change that to times this guy's reciprocal. I personally think that'd be a better option. It's a lot less writing, it's more direct, which again is why I'm not putting the book's other method in our notes. So this is, again, the first method that we wrote in our notes. So just to point this out, I've got this guy here, which is this guy here, and then we have the denominator, which of course becomes a reciprocal when we change to multiplication. So then if I were to do it like this, again, C and C would cancel, B and B would cancel, nothing on top, which means it's a 1, and then 2D on bottom. That would be perfectly acceptable as well. So if we go back to the practice problems, we're going to move on to C. So for C, I have 4x squared over x minus 3, and all of that over x over 3x minus 9. Now for this one, I look at those two denominators, and this time I don't want to go with this method here. I might look at this and say, okay, we got binomials, or if you have trinomials, I'm more likely to say, let's not look for a common denominator between those. Let's go ahead and rewrite this as a multiplication problem. So the top fraction stays the same, and then the denominator, excuse me, the top fraction stays the same, and then the denominator here is going to become a reciprocal. So that means x was on top, so now x is on bottom. When I write the top here, though, notice that we can factor a 3 out of it. So I'm going to do that right now. So I'm going to factor that 3 out, and so that's going to make an x minus 3. And now what we have is two fractions where we're multiplying, which means that we can reduce before multiplying. Remember that we treat denominators like quantities, so this is really the quantity x minus 3. So this will cancel that. For that matter, this single x will cancel a single x up there, And so if I go to simplify this then, everything in the denominator is canceled. That means they're all ones. And if you have a 1 in the denominator, it's going to disappear. So up top, I have a 4 times a 3, and I have an x. So this is going to be 12x. So that simplifies down quite nicely. 12x. D, when I look at D, D, I have to write real small here because I got, I guess, yeah, 1 over m plus 5, and all that over 2 over m minus x over m. This is another one where I'm going to go with the LCM. Because when I look at my internal fractions, even if I were to use the method we used on C, you're going to find out you're still going to have a complex fraction. So I like the idea of just looking for those common denominators. And this one's particularly easy because with a denominator of m, and m, obviously the least common multiple of the same number is the same number. Or in this case, the same variable. Oops, sorry. So I'm going to multiply by m over m. Up top, when I distribute this in, don't forget because there's a plus sign there, we're going to distribute this. When I distribute the m to the 1 over m, they're reciprocal, so that's just going to be a 1. And then when I distribute that to the 5, that's going to be plus 5m. So realizing that, I'm just going to throw it in standard form real quick. 5m plus 1. In the denominator, both of these m's will cancel with that. They're just gone, which means this is really just 2 minus x. Now I could make this at negative x plus 2. That would also be acceptable. But sometimes when we have subtraction like that, we just go ahead and leave it subtraction. So this would be a perfectly acceptable final answer. And then finally, letter E. If it took Ariel 5x squared minus 45x all over 5x minutes to walk to school, that was 3x minus 27 all over x cubed miles away, find her rate in miles per minute. So ladies and gentlemen, remember that per mathematically means divide. So if I set this problem up the way the book is intending, I'm going to take my miles, so my number of miles here is 3x minus 27 all over x cubed, and then I'm going to divide it by, which as we progress in algebra, we typically don't use a division symbol. This is one time that we could make an exception, but since the whole point of the lesson is complex fractions, we're going to express this as a complex fraction. So all of that over the number of minutes, so miles per minute. So minutes here is 5x squared minus 45x, and that is all over 5x. Again, because I have binomials in both of those internal numerators, I like the idea of going with this first method. To think of this as a division problem, to think of that as a division problem, and therefore change it into times the reciprocal of the second fraction, the bottom fraction. So up top, we're going to leave 3x minus 27 as itself. I've got to slide that over just a little bit to leave quite enough room. And then in the denominator, we just have x cubed. For our second fraction, the denominator, it'll become its reciprocal, so that'll become 5x over, and then we can go ahead and actually factor there. So I see a 5 and an x can both come out, and then I'll have x minus 9 left over, and actually I Should have done the same thing right here, so let's go back and do that. So noticing a 3 can be factored out of both of those, and we'll take a 3 out and be left with an x minus 9 behind. And now we reduce. Well, a 5x will obviously cancel with a 5x. This quantity will cancel with that quantity. And then up top, all we have is a 3. And on bottom, all we have is an x cubed. So this will be 3 over x cubed. And since this was a story problem, we're going to go back and look for the units. And the units here are miles per minute. So once again, ladies and gentlemen, just to recap, the ideas here are you can either look at the internal fractions and find a common multiple, common denominator. The least common multiple would be the best, and multiply that as a form of 1. The other option is you think of this as your first number divided by your second number, and you change it into the first number times the reciprocal of the second. And that, ladies and gentlemen, is the end of our lesson.